Hello my friends, and welcome again to the 12th and final class in our series today, into which, my friends, we are answering the 2024 British Pearson Edexcel International GCSE past paper, and our subject today, my friend, is chemistry. Today, my friends, we are going to answer the last question. This question is about tantalum, which is an element in the periodic table. Tantalum metal can be produced by heating tantalum chloride and hydrogen gas in a furnace. A furnace, my friends, is an apparatus into which we put a chemical material. Here, this is, for example, a chemical material. Here, this is the furnace. Here, and here we put the chemical we want, and we set fire under it so that we heat it up. Here we heat the mixture, this chemical material, which is solid, tantalum chloride, with hydrogen, as you see here, my friends, to receive tantalum and HCl. So those are reactants and those are products. Let's see what do they want. As you see here, my friends, as tantalum chloride is heated, the mass of solid in the furnace is decreasing. This is normal, my friends, because in the furnace here we have the tantalum, TaCl2. Here, this is the solid. And of course, we have hydrogen here. We pump hydrogen here, hydrogen gas. This hydrogen will steal the chloride and it will leave like HCl. So the gas is going to be withdrawn, here HCl. So we are technically stealing the Cl from the tantalum. So the tantalum will stay alone after a while. So the mass of tantalum chloride, or the mass of the chemical inside the furnace, will what? Will be decreasing because we are losing the chloride. The mass of solid furnace decreases, as we said before, because we are stealing the HCl. We're stealing the Cl in the shape of HCl, and it leaves like a gas. And the solid chemical, only the solid matter will stay in the furnace. Here, the table shows the mass of the solid. Here at the beginning, we had TaCl5, how many kilograms? 2,510. After a while, 1 hour, we will lose some chloride, so the mass will be decreasing. So it's 2,200. Then, after 2 hours, 1,900, till we reach 5 hours. Here, 5 hours, we notice that the mass is not changed. Why do we say that the mass is not changed, my friends? The mass is not changed because we don't have any TaCl5 anymore. So this mass here, my friends, is going to be what? The mass of tantalum. Mass of tantalum alone. Why, my friends? Because it doesn't have any chloride to lose anymore. So, state how the data in the table shows that reaction is complete. As we said, because the mass of the solid inside the furnace doesn't change. So the mass of the solid in the furnace doesn't change. Let's see here, my friends, the mass of each one. Of course, the mass of tantalum alone is 100 to 1,267. How did I know? I knew, my friends, because as we said here, at the beginning of the reaction, we had TaCl5, and the Cl is escaping, so the mass is reducing. When we reach here, this is the mass of Ta, tantalum alone, because the reaction stopped, as we said before. When the reaction stopped, we understood that we had only tantalum in the furnace because it is solid. The gas was, or the gas escaped. So the mass of tantalum alone was this value, 1267. What about the mass of tantalum chloride together? The tantalum and the chloride together, it is the first mass we have taken as they showed us at the beginning. This is the beginning. We had tantalum and chloride, and nothing was lost. So this is the initial mass in the furnace. Now, if we know the mass of tantalum chloride together and we know the mass of tantalum alone, we can calculate the mass of chlorine alone. So the mass of chlorine is the whole mass minus the mass of tantalum. Here, TaClX, let's say. We're not sure that Cl5. We say this is the whole mass of tantalum and chlorine together, and this is the mass of tantalum alone. So the mass of chlorine is 1243. So this is the mass of tantalum, which we got from the data of the chart, and this is the one we calculated after we substituted the tantalum from the whole mass. Now, what are the steps of Mr. Udait's empirical formula chart? As you know here, my friends, these masses or percentages are given in the question. This we calculated. Now we divide them over the AR. We have this mass over 181 and this mass over 35 should be 35.5, not 35, 35.5. Now the numbers here are 7 and here we have 35. Then we divide to calculate the ratio. To calculate the ratio, we divide number of moles over number of moles minimum. Which one is minimum? Which one is higher, 35 or 7? Of course, 35. So 7 is the minimum. We divide both of them over the minimum, so that this is going to be 1, tantalum 1, and chloride will be 5. So the formula is tantalum Cl5. After we divide them over number of moles minimum, we say the ratio. The ratio means each one tantalum atom needs 5 chloride atoms to make the formula, into which the masses are like this. So these masses need these ratios, and these ratios give this formula. Now, my friends, let's move to the last page. Here, another method of extracting tantalum is by reacting tantalum oxide. This is tantalum oxide, not chloride this time, with carbon. Again, in the previous reaction, we had tantalum chloride, and the hydrogen steals the chloride and leave with it to make HCl, and the tantalum stay alone because we want to extract the tantalum. Here we have tantalum oxide, and the carbon will steal the oxygen and will make carbon monoxide and leaves, and the tantalum will stay alone. Now, explain why this is a redox reaction. What do we mean by redox reaction? Redox means reduction. Here, reduction and oxidation. Redox means, it comes from red means reduction, ox means oxidation. So why is this reaction reduction and oxidation? The answer is easy. What is oxidation, my friends? Oxidation is when a chemical compound gains oxygen. So carbon here gains oxygen from tantalum oxide. So carbon is oxidized, while tantalum here, my friend, loses the oxygen. So it is reduced, because reduction means the loss of oxygen or the gain of hydrogen. Here, tantalum lost oxygen, so it is reduced. Last question here, my friends. As you see, we have, to answer this question, we have two methodologies. I'm going to try to answer them one by one. Let's start reading the question, then we read the answers. 2,000 moles of tantalum oxide. So we have 2,000 moles of tantalum oxide. This is Ta, number of moles, let's write it here, number of moles of tantalum oxide, 5 equals 2,000 moles. Okay, this is number of moles. And we have, is heated with 5,000 grams of carbon. Good. Show by calculation that carbon is in excess. What do we mean by carbon is in excess? Generally, my friends, in this reaction, we need to extract the tantalum. Tantalum oxide is not a good chemical material. Let's say it's very cheap and it cannot be used in industry. We need to take the tantalum alone. So we put an amount of carbon and we heat them together so that the carbon will steal the oxygen and it will give us pure tantalum. Now, they say we have 2,000 moles of this chemical material and we have added 500,000 grams. So we need to change this into grams to know how many grams of carbon do I need for 2,000 moles. 2,000 moles, here the mass equals number of moles multiply MR. Let's see the MR. If we calculate the MR now, we multiply it with the number of moles so that we know what? The mass, here, the mass of what? Of tantalum oxide. We see how many grams of carbon do we need for tantalum oxide. So, number of moles here of tantalum oxide, and now we need to see the MR. The MR here is easy. We know that carbon is 12 for tantalum oxide. The tantalum is 181 from the previous page, and we all know that oxygen is 16. Oxygen is 16. So we have 2 tantalum oxide, two tantalum atoms. We have Ta 181 multiply 2 plus 5 oxygen. Oxygen is 16. Teacher, how did you know oxygen is 16? You can always go back to the periodic table and take the mass number from the periodic table if you don't have them here. Generally, in the questions, they give the ARs for you, AR of tantalum, AR of oxygen. This time they haven't given us, so we can go back to the periodic table, and the periodic table will provide us with the mass number and the atomic number. Of course, the mass number is the highest number. So we multiply them, and then MR is 442. So we know that from the equation, here, theoretically, each 1 mole of tantalum, you see the equation, each 1 mole of tantalum oxide, as you see here, which is 442 grams per mole. So 1 mole is this amount of grams, needs 5 moles of carbon. So what is the mass? The mass equals number of moles multiply AR. And we see that AR is 12, so it is 5 multiply 12. So theoretically, each 1 mole of tantalum oxide, which is 442 grams, needs 5 moles of carbon, which is 60 grams. But we don't need theoretically, we need practically here. How much do we have? We have 2,000 moles of tantalum oxide. So each 2,000 moles of tantalum oxide, which has the mass 884. How do I know? It's the mass, as you know, my friends, M equals N multiply MR. The N here, my friends, is 2,000 moles, and MR, this is the MR. We multiply 2,000, multiply this, 2,000 multiply MR, which is 442, we get this number. Needs how many grams? X. We made our calculations, as you see here, my friends, cross multiplication. We multiply this one with this one, and we divided over 442. In here, my friends, the number is 120,000 grams. Now, we need for this 2,000 moles, which is 884 multiply 10 over exponent 3, we need 120,000 grams of carbon. But how much carbon do we have? We have 500,000. So we have here 500,000 grams of carbon. So carbon is in excess. 120,000 will react, and the other, the rest will stay as it is. This is the first way. The second way, my friends, here is written, which is, in my opinion, easier, but some students told me, the teacher, it's difficult. The other way depends on calculating the number of moles we need of carbon to react. So we say each one mole of tantalum oxide needs 5 moles of carbon. Okay? So we have here theoretically. Here practically we have 2,000 moles of tantalum oxide. So we need N mole of carbon. So the N mole here, 1 mole needs 5. 10,000 moles, of course. 2,000 moles need 10,000. Or you can cross multiply them, as you see here, my friends, 10,000 moles. So what is the mass of carbon? The mass of carbon is number of moles multiply the AR. So here we need 10,000 moles of carbon multiply the AR, which is 12. So we need 12,000 grams of carbon to react with 2,000 grams or 2,000 moles of carbon. So we have 500,000, so carbon is in excess. Now, my friends, let's go to the last question here. Calculate the maximum mass in grams of tantalum can be obtained. Also here, my friends, we have 2 ways to calculate these numbers. We know that, again, each 1 mole of tantalum oxide, which is 442, we calculated it here. From here, this is the MR1, the mass of 1 mole. Molar mass is the mass, gram, for 1 mole of a chemical material. So each 1 mole, which is 442 grams of tantalum oxide, gives 2 moles of tantalum. Good. Which is 362. Teacher, how do you know 300? Because, my friends, this is AR. Here, mass equals number of moles, which is 2, multiply AR, which is 181. So 2 multiply 181, this is number, this is the mass. So each 2,000 moles, how many grams do they make of tantalum? We cross multiply them. This one, multiply this one over that one, as you see, my friends, and the number here is given, please calculate it and put it. And here, my friends, we have another way. If you want, we have another way to calculate the same number. We go back to number of moles. As we see here, my friends, we have 1 mole of tantalum oxide gives 2 moles of tantalum. So 2000 moles gives 4000 moles, right? 1 mole from tantalum oxide, I'm repeating, 1 mole of tantalum oxide makes or gives or produces 2 moles of tantalum. If I have 2000 moles of tantalum oxide, I get, of course, 4000 moles. Now, we change the moles into mass. Mass is number of moles multiply the AR. So, we take 4000, which is number of moles, multiply the AR, which is 181, and the number is 724,000 grams of tantalum. And we write the same number here, 724,000 grams of tantalum. Till here, my friends, we have finished this paper. I hope that you enjoyed and you learned something new with me. For more information, my friends, don't hesitate to get in touch with me. You have the links on my YouTube channel you can use to get in touch. Thank you, my friends, and goodbye to a new past paper.